Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution. Imagine every point on this grid as a real location on a map. Each point has an address given by its coordinates. Now suppose we want to travel from point A to point B. How far apart are these 2 points? Instead of measuring with a ruler, mathematics gives us a precise way to calculate this distance using coordinates. This idea leads to one of the most powerful tools in coordinate geometry, the distance formula. And once we understand it, we can solve many interesting problems like finding missing vertices of triangles, locating points that are equally distant from others, and even completing shapes on coordinate planes. At first, we will see how to use distance formula in simple questions. Let's say we have 2 points A x1 comma y1 and B x2 comma y2. So the distance between AB is given by, you already know what is distance formula. Here I'm not going to tell you the formula, but instead I'll tell you how to use it quickly. So first I'll write the coordinate of A, any coordinate you can write. Here I'm using A, so x coordinate and y coordinate, and then the coordinate of B, x2 and y2. Now you just change the sign of any one of the coordinate. That's your choice. You can either change x1 and y1's coordinate or x2 and y2's coordinate. Then just add them up. So you will get x1 minus x2, and here you are going to get y1 minus y2. Just square and write down. Whatever value you get, you will square it up and write it down here. Take the square root, and this will give you the distance between A and B. Let us take, for example, we have to find distance between the points A 7 comma minus 4 and B minus 5 comma 1. So what is the distance between A, B? As I've told you before, we are going to write A's coordinate, x coordinate and y coordinate, and B's x coordinate under x column and y coordinate. Okay, let's change the sign. So here let me change the sign of B's coordinate. So this becomes plus and this becomes minus. Now we are just going to add it up. So 7 plus 5 is 12 and minus 4 minus 1 is minus 5. Now we just have to take the square. So we'll square it up and add them up. So plus minus 5 square. When we square a negative number, we get a positive number. Don't forget the square root. Now many of you have made a mistake that 12 square, they take 12 out and 5 out, then add them up, 12 plus 5. Do not do that. Square root operation doesn't happen like that. Okay. We'll have to figure out 12 square, that's 144, plus minus 5 square is just 25. 144 plus 25 is square root of 169. That's 13 units. So you see, it's very simple. Let us take one more example. This. Here instead of numbers, I have used parameters. So we'll apply the same method. We will write the x coordinate and y coordinate in separate columns. So let's start with A. X coordinate is x plus y and y coordinate is x minus y. And for B, we have x minus y and minus x minus y is the y coordinate. Now we have to change the sign. Let me again choose B only. So it becomes minus x and plus y, right? And here I get plus x plus y. Be very careful. So you have to change all the signs. So now we add them up. So x minus x, this gets cancelled. Plus y is just 2y. Here x plus x is 2x while y gets cancelled. So the distance AB is equal to square root of first value 2y square plus next value 2x square, right? So we get 4y square plus 4x square. We can take 4 common. So y square plus x square. And out of 4, 1, 2 can come out. See, it's multiplied. So when it's root a into root b, we can definitely write square root of a and into square root of b. So I'm using this property here. But the same cannot happen if I replace multiplication sign by a plus sign. We can never write root over a plus b as root a plus root b. That's wrong. These two are not equal. Okay, so let me clear this up. Now here, since there is a multiplication, so square root of 4 gives me 2, and from this part nothing can come out. So this is the answer. Units, because it's distance. Now that we have understood how to use distance formula, next is how to use distance formula easily when we find distance from the origin. So distance of any point from origin is square root of x square plus y square. Why? Let us understand. So if I write P's coordinate x and y, okay, and origin's coordinates are 0 and 0. So we change the sign of this one. So x minus 0 is x, y minus 0 is y. Then you know we have to take a square root and then square sum of the squares, right? So that is why this is the formula. So easily we can find out. Let's say we have to find out distance of point P 4 comma minus 3 from origin would be square root of 4 square plus minus 3 square. So which is equal to 16 plus 9. That is equal to square root of 25, which is equal to 5 units. Now let's apply the distance formula to solve some interesting coordinate geometry problems. Let's see this question. The coordinates of the center of a circle is given to be this. We have to find the value of A if the circle passes through the point this. Let us try to visualize the problem. Let's say center is denoted by the letter C. Okay. Find the values of A if the circle passes through point. So this point is lying on the circle. Let's call this point A. So we have to find the value of A and the diameter is already given. So if diameter is equal to 10 root 2 units, which means the radius is equal to diameter by 2, which is equal to 10 root 2 by 2, which gives me 5 root 2 units. And what is radius? It's simply the distance between C and A, right? So here we use distance formula. It's better to square both sides. So I'll use CA square equal to R square so that we get rid of the square roots. So let us do our work. So C's coordinates are 2A and Y coordinate is A minus 7. Remember I'm writing X coordinate and then Y coordinate. And A's coordinate is 11 and minus 9. Let us change the signs. So here it becomes minus and there it becomes plus. So we get 2A minus 11 as the X part and the Y part. A minus 7 plus 9. So A plus 2. Now you know we don't have to give square root anymore. So we have 2A minus 11 whole square, because we have to take the square of the difference, right? According to the formula, plus A plus 2 whole square, which is equals to R square is 5 root 2 square. Now we will expand this using the formula A plus B whole square equal to A square plus 2AB plus B square. So we get A square minus, because here I have to use A minus B whole squares formula. 2A into B plus B square, which is 121. Same thing over here. We'll apply A plus B whole square formula. 2 into A into B plus B square, which is 4. And here we get 50. 5 root 2 square is 50. Right? So we have, now let's just do the calculation. So after adding these two, I got minus 40A. 121 plus 4 gives me 125 equals to 50. Now 50 will come this side. So 125 minus 50 gives me 75. So we get 75 equal to 0. Now throughout I can cancel by 5, right? So we have this. And now we can do middle term break, right? To factorize. So we will get a minus 3 into a minus 5 equal to 0, which means a's value is either 3 or 5. Now, note that in question itself they have asked find the value or values, which means more than one answer was possible. So here we got two answer. Value of a is 3 or or 5. So once again, we used the idea that the distance between the center and any point on the circle is equal to the radius, and the distance formula helped us find the missing coordinate. So now let's look at another interesting coordinate geometry problem. Find a point on x-axis which is equidistant from these 2 points. Here we have to find a point on x-axis, and any point on x-axis is of the form x comma 0, right? The y coordinate becomes 0. So let the point be px comma 0, which is equidistant. Equidistant means at equal distance. So p is at equal distance from these 2 points. Let's name the points a and b. So which means PA is equal to PB. Now we don't want to deal with square roots, but in distance formula we have to use it. So I will write PA square equal to PB square so that we don't have to write square roots. Okay. Now let us find the distance between P and A, where we have x and y coordinate is 0. For a we have minus 2 and 5. You know that we have to change the sign. So I'm changing the sign of a's coordinate. So we have x plus 2 here, and y part becomes 0 minus 5, which is minus 5. But it doesn't matter whether we have minus 5, because when we square, it becomes positive. So minus 5 square. Similarly, PB square, P is x comma 0 while B is 2 and minus 3. Let's change the sign, minus, and this becomes plus. So we have x minus 2 here, and 0 plus 3 is 3. So x minus 2 whole square plus 3 square. Now let's solve it quickly. Expand it using identities. So we have equals to x minus 2 whole square. We'll use a minus b whole square equal to a square minus 2ab plus b square. So, and 3 square is 9. Please note x square and x square gets cancelled from both sides. Plus 4 and plus 4 also gets cancelled. So let's take all the x on one side and all the constants on the other side. 9 minus 25 is minus 16. So the value of x is minus 2. So the required point is p minus 2 comma 0. So this is the point on x-axis which is at equal distance from the two given point. Now if in this question, if the question had asked for a point on the y-axis instead of x-axis, we would simply assume the coordinates to be 0 comma y and proceed in exactly the same way. Now let's look at another question. Find a point which is equidistant from these 3 points. So since nothing has been mentioned over here, x-axis or y-axis, we have to take the point to be px comma y. Let's consider the given points to be a, b and c. Now we have pa is equal to pb is equal to pc, right? So the squares of each of them are also equal. Let's start with pa square equal to pb square first. So pa square equal to pb square. Same way we are going to find out the distance. So here I'm not showing it anymore. I've done already in past 3 questions. So x minus 3 whole square plus y plus 4 whole square, which is equal to pb square is going to be x minus 1 whole square plus y minus 2 whole square. You can definitely pause the video, do your own solving, and then match it with mine. So we expand both sides using the identities that we know. whole squares identities, and from both sides x square and y square terms will get cancelled, and so we'll be left with this. Now let's take all x and y's on one side and all the constant on the other side. So we get minus 6x plus 2x gives me minus 4x plus 8y plus 4y gives me plus 12y, and 9 plus 16, which is 25, which goes on the other side. So 5 minus 25, that gives me minus 20. Throughout we can cancel by 4, we see. So we have, let me cancel by minus 4. And how do I do it very quickly? Just divide my minus 4. Each and every term is being divided by minus 4. So we get x minus 3y equals to minus gets cancelled 5, right? So find the value of x from here, which we can use later on in any other equation. So 3y plus 5. So we have used only first two. We are still left with pb square equal to pc square, right? So pb square, once again we'll use the same way of finding distance, but here I have already found out pb square. I'm just going to copy paste from here. So x minus 1 whole square plus y minus 2 whole square, while pc square, p and c is over here. So x minus 5 whole square plus y plus 6 whole square. We will expand using identity, and x square and y square terms will get cancelled from both sides. So we'll be left with this part is just copy and pasting of this. Here we will solve, so we'll get, so taking all the x and y terms on one side and all the constants on the other side, we get, so plus 10x come here, so we get plus 8x minus 4y minus 12y minus 16y, and 5 goes that side. So we get 20 plus 36, which is equal to 56. Throughout we can cancel by 8. So we get, in place of x, I can use this value, right? So we get 3y plus 5 minus 2y equal to 7. And solving which, 3y minus 2y is y, plus 5 goes that side. So 7 minus 5, that's just 2. So value of y, we have got 2. Therefore, x equals to, we know 3 into y plus 5, that's 11. So the required point is P 11, 2. So this point is equally distant from all the three given points A, B, C. So this shows how the distance formula helps us locate a point that satisfies certain distance condition. Now let's move on to the next geometry problem. Distance formula can also be used to show three or more points collinear. For this, let us consider the first point A, second point B, and third point C. Using distance formula, we can find out the distance between AB, BC, and AC. So let's do that. The same method over here as I've shown in the first question. A is 4, 3, B is 5, 1. So let's change the sign of A now. So 5 minus 4, we have 1. 1 minus 3, we have minus 2. So here we write square root 1 square plus minus 2 square. So which is 1 plus 4, and that is just root 5 units. Similarly, we'll find out the distance between B and C, which is equal to 16 plus 64, and that is equal to 80. Now 80 can be broken into right from here. I get 2 and 2 out, so 4 root 5 units. Don't forget to write units. Similarly, we calculate AC, which is equals to 3 square, and 3 minus 9, that is minus 6 square. So that gives me 9 plus 36, which is equal to square root 45, and 45 is basically 9 into 5, so 1 3 comes out and root 5. Now clearly the biggest over here, the largest value is 4 root 5 units. I leave that as it is, aside, and we will calculate AB plus AC, so which is equal to root 5 plus 3 root 5, which is equal to 4 root 5, and which is equal to BC, which means it's clear that B lies between A and C. So which means points A, B, C are collinear. Our next question is to prove that the points, let's say the points are A, B, and C, are the vertices of an isosceles right triangle. For an isosceles right triangle, I have to show any of the two sides are equal, and for right triangle, we need to satisfy Pythagoras theorem. So first, let us calculate all the length using distance formula. So just how we have done example 1, remember? So I'm going to calculate, and I'm not going to show right now. Moving on to BC. Don't forget to write units. Then AC. Now obviously BC is equal to AC. So triangle ABC is isosceles. Now this is obviously the largest side. So we'll keep this aside and we will calculate the sum of the squares of other two sides. So which is equal to 2 square plus 2 square, and that is 4 plus 4, which is equal to 8. And isn't 8 the square of square root of 8, right? That is, it is equal to AB square. So by the converse of Pythagoras theorem, we can say that triangle ABC is angled at C. So therefore, triangle ABC is an isosceles right triangle. Now, if it's a right triangle and right angled at C, which means AB forms the hypotenuse, and to find out the area of this triangle, we have the area of the triangle is half into base into height. Base is 2 units, height is also 2 units. So area of the triangle is half into 2 into 2, which 2 gets cancelled and we get 2 square units. Now, before we move on to the next question, I want to go back to this question. Find a point which is equidistant from 3 given points. The same question can be reframed as find the, instead of point, coordinate of the center of a circle passing through these 3 points A, B, C. Here we will apply the same idea. So let's say this is the circle. We'll consider the center as Px comma y, and this is the circle with center P, and the 3 points A, B, C are lying on the circle. The key idea over here is that the center is equidistant from all the points lying on its boundary. So which means PA square equal to PB square equal to PC square. So we'll apply the same process, and the value of x and y that we'll get will give me the coordinate of the center of the circle. Now, what if they ask us to find the radius of the circle as well? So once we get the center, we can actually find out the radius by calculating the distance between the center and any of these points, either A, B, or C. So PA will give me, or PB or PC will give me the radius of the circle. So our next question was exactly this. Find the center of the circle. So we'll take the center of the circle as, let's say, C, x comma y, and we'll proceed like before. C is equidistant from PQ and R. So CP will be equal to CQ will be equal to CR, as well as their squares will also be equal. And we'll get the values of x and y. Since we have already done a sum like this, so I'm not doing it once again. We are moving on to the next question. The next questions are questions of these type, where certain points will be given and we have to prove that the points are the vertices of a particular quadrilateral. For this, we need to know the properties of sides and diagonals of the quadrilateral. For example, for a square, all sides are equal and diagonals are equal as well. So we need to calculate first all the length of the sides, let's say AB, BC, CD and DA. These are the sides whose length we can calculate using distance formula, and we are expecting that we'll get all the lengths equal. If you're not getting, that means we have made some mistake. For example, over here, AB is 4 minus 1, that is 3 square, and 2 minus 7, which is 5 square, minus 5, but since we are squaring, so negative sign will go away. So that is 9 plus 25, which is equal to square root 34 units. And I hope that all the distances you will get as square root 34 only. Then you can draw your conclusion that therefore AB is equal to BC is equal to CD is equal to DA. But this alone is not enough to show that they are the vertices of a square. You need to find out the length of the diagonals as well. So we need to calculate AC and BD. Because we know for a square diagonals are also equal. So since the sides as well as the diagonals are equal, then we can say that they are the vertices of the square. So calculation of AC, so 1 plus 1, which is 2 square, and 7 plus 1, 8 square. So you can calculate this out. Over here BD, 4 plus 4, 8 square, and 2 minus 4, which is minus 2 square, that becomes plus 2 only because we are squaring. And so we see we are getting exactly same values, right? So the diagonals are also equal and hence they are the vertices of a square. Now what if they ask an additional question over here? Also calculate the area. So how do I calculate area? For finding out the area, here we are going to use the formula of area of square, which is square of the side. Now the sides are square root 34. So square root 34 square is just 34 square units. That's it. Now show that the following are the vertices of a rectangle. What do you expect? We'll proceed in the same way. First we'll find out AB, BC, CD, DA. Obviously two pairs will be same. So AB will be equal to CD, BC will be equal to DA. And we'll also calculate diagonals. Diagonals will also be equal because for rectangle and square, length of diagonals are always equal. And in case they are asking us to find the area of the square, we'll multiply, and in case they are asking us to find the area of the rectangle, we'll multiply the length and breadth. Now moving on to the last question, show that points these are the vertices of rhombus ABCD. So which means once again we'll calculate the sides and the diagonals, which I did. Like this. Not only that, I've also calculated area in case there is a question asking us to find the area of the rhombus. Area of the rhombus is given by the formula half into product of the diagonals. So these were the sides where I got all sides as 3 root 10 units. Now it's not mandatory to take things out over here. You can keep it as root over 90 units because 3 square is 9 and 9 square is 81. So that gives me root over 90 units. We could have kept it like that only. So that brings us to the end of today's problems on application of the distance formula. Practice similar questions to strengthen the concept, and we will continue exploring coordinate geometry in the next video. And if you have enjoyed this lesson, don't forget to like the video and subscribe for more mathematics lesson only on Think Sharp Alley.